Algebra. Here are the notes for 9.3 day 1. So we can factor monomials and binomials, but what happens when we see a quadratic polynomial? Well, a quadratic polynomial, first we need to know what it is. So let's just zoom in here. So a quadratic polynomial is a polynomial with highest degree of 2. And it's going to be in this form. So it's going to be in standard form. So we need to always have it in standard form when we're working with it. ax squared plus bx plus c. Notice my variables go in descending order. So I have x squared, x, and c. So when something is in standard form, let's look at the information given below and see if we can see a connection. So if I tell you that x squared plus 11x plus 24 is the same as something broken down like this, I'm essentially looking for a connection between the numbers. I've got an 11, I've got a 24, a 3, and an 8. Well, as I start to look at this a little bit, I notice that 3 plus 8 could get me that middle term of 11. And I notice that 3 times 8 could get me that end term of 24. So this next one says need a hint. Well, if I look at this again, does it work the same way in another scenario? If I have x squared plus 6x plus 9 equals 0, I do notice that 3's not only add to 6, but they also multiply to 9. So it looks like when we're going to start using this pattern, that's how we're going to be factoring these quadratic polynomials. So let's solve the following. If I have x squared plus 6x plus 8. Well, my first step is to set it to 0 if I can, because I need to make sure that all of my terms are on one side. So set equal to 0, just to make sure I've got everything in one place. My second step is going to see what multiplies to 8. So write the factors of 8. And you're going to want to write all of the factors out. So write the factors of 8 or of your C term, which is always this term that has no variable attached. So my factors of 8 are 1 and 8 and 2 and 4. Once I have my factors, I need to see what pairs could be used to find B. So what pairs could be used to find the number 6? Well, if I look at these pairs, I notice that adding a 2 and a 4 could get me 6. So what I can do is use this pair in my equation. So I'm now going to write the general form of something that's factored. Well, the first 2 blanks are going to need to multiply to x squared. So we always put an x and an x in those first 2 blanks. Then we know that the second 2 blanks always have to multiply to the right term there. So the 2 and the 4 are the ones we're going to use. Now, why did we use those? Because by putting it in this form, we can naturally see that these 2 terms then add to 6. So the same pattern that we were working with up here now works down here. So write general formula or general form of factors. Where something's there. So let's see another example of this. And maybe the steps don't make as much sense to you as just seeing the pattern. So essentially each time we're going to find out what multiplies to C and adds to B. So let's go down here. My B in this case is 9 and my C is 20. So these are already set equal to 0, which means I don't have to move any terms around, and they're already in standard form. So now I'm going to write the factors of C. I've got 1 and 20, 2 and 10, 4 and 5. Now I need to see what adds to B. So what multiplies to C? These terms. Now what adds to B? Well, a positive 4 and a positive 5 will add to 9. So I'm going to use my final step here and say set it up as the general form. I've got an x and an x. The two x's multiply to the first term. The 4 and the 5 multiply to the third term. And by naturally finding what pairs add to 9, a positive 4 and a positive 5, the 9 works. Now I could check this by foiling it out, and I could see if it works. However, I'm going to tell you that I know for a fact this does, so I'm not going to do that. However, if you'd like to pause the video, go right ahead and test it. All right, let's do another one here. I'm going to list the factors of C, in this case, 1 and 10, 2 and 5. Now you're going to ask, why didn't I take this negative into account? Well, I'm about to. This negative means that one of these terms has to be negative, but I don't know which one. That's what this middle term is going to tell me. So when it comes to having a positive 3, how do I get that out of these pairs? Well, if I take 2 and 5, I see that I can get a 3 out of it, and to get a positive 3, I know that I have to make the smaller number my negative. In doing that, I now have negative 2 times 5, which is negative 10, and I have 5 minus 2, which is a positive 3. Now, if that had been negative, I would have had to have made the larger term negative, and you'll start to see that pattern a little bit more as we go. So now I'm going to take the pair that I found, and I'm going to put it into that general form again. Remember, x and x, those multiply to the first term. 2 and 5 multiply to the third term. By making one of them negative, the negative 2 and a positive 5, I get the middle term. All right, let's see one again. What multiplies to C? 1 and 30, 2 and 15, 3 and 10, 5 and 6. What adds to negative 11? Well, I know if something has to add to a negative number but multiply to a positive number, both of them have to be negative. So I can actually go in here if I choose to and write the form like this. If I know both numbers can be negative, have to be negative, I can write these in as both being negative. Now, which of these could I make negative to get to a negative 11? Well, 2 and 15 don't make 11. 3 and 10 don't make 11. But a 5 and a 6, or a negative 5 and a negative 6, do add up to that negative 11. So it's a lot of searching for those patterns. What multiplies to C and adds to B. All right, let's flip it over and keep going. What multiplies to 18? 1 and 18, 2 and 9, 3 and 6. Now, how do I get a 11 out of that? Well, I can't do it from a 1 and 18, but I can do it from a 2 and a 9. So I notice everything's positive in this case, so a positive 2 and a positive 9 will work just fine. Negative 6, I have a 1 and a 6, and a 2 and a 3. Now, I will put these in here knowing that one has to be positive and one has to be negative. How do I know that? Well, I know that to multiply to a negative, one has to be positive, one has to be negative. Now, you thought, or your first thought is 2 and 3, but there's no way with a positive 2 and a negative 3 or a negative 2 and a positive 3 to get a negative 5. So we have to go back to this set of factors and see that we need a negative 6 and a positive 1 in order to factor that one. All right, I'm going to take off the training wheels a little bit here. I'm just going to keep going with it. Multiplies to C, adds to B. X minus 4, X minus 2. Negative 4, negative 2, add to negative 6. Negative 4, negative 2, multiply to 8. All right. Multiply to 2, add to negative 5. There's no possible way. There's no combination of negatives that are going to get us to negative 5 in this case. So we don't actually have a way to do this one with whole integers yet. So I'm going to put no solution yet. In some of the coming lessons, we will learn about some more tips and tricks to solve these, but there are on occasion going to be some that we don't know with the current methods. All right, next one. What multiplies to 72? We have 1 and 72. We have 2 and 36. I believe we have 3. Let me double check that on my calculator. So 72 divided by 3, we do. It's 24. What else do we have? Does 72 divide by 4 nicely? It does. 4 and 18. I know I don't have a 5 because it doesn't end in a 5. A 6 does give me 12. A 72 does give me, it's not divisible by that, but maybe by an 8. Yep, so 8 and 9 will be my last ones. And which of those pairs could I use to get a negative 1? Well, I can do a negative 9 and a positive 8 because I know a negative and a positive multiply to a negative. And I can add them to be a negative 1. All right, last one. We got 1 and 18, 2 and 9, 3 and 6. How do we get to a positive 3 when we know one of our factors has to be negative? Well, we do a positive 6 and we do a negative 3. All right, there are a ton of excellent videos out there on the web if you're looking for more practice just going through these. Otherwise, let's read this piece at the bottom. This is one of the most important skills you'll learn in algebra, and you only get better with practice. So please spend a ton of time practicing this. It's going to be a very, very useful skill, not only for the rest of the year in algebra, but also in the coming years of your math career. Let me know if you have any questions.